How to find the distance between two planes. First of all, I'm going to elaborate on two cases that define distance and do not define distance between two planes. For the first case, the distance cases describe the magnitude of distance will always be begin zero. While for the second case, the zero cases states that the magnitude of distance will always equal to zero. Now, what are the distance cases that can define distance between two planes? Now, the first distance case will be the parallel and distinct case. Say you are given two planes, plane 1 and plane 2, they are parallel. The line or the normal line that is formed between the planes will describe the shortest distance. This is also true for the non-parallel and distinct planes, meaning the direction vectors on the planes are not scalar multiple of one another. The same concept applies here as well, as the normal line that is formed between the planes would describe the shortest distance. As for the zero cases, distance will not be defined for planes that are parallel and coincident. The reason for it is because the plane coincide, essentially meaning all the points on each of the planes are equal. That means the shortest distance between them is zero. This is also evident for intersecting planes, as the intersecting lines at the two planes will define all the equal points on both plane 1 and plane 2, which technically referring to zero distance. So how are we supposed to find the perpendicular line between any two planes? The perpendicular line here only describes to where the shortest distance will be, and it has to be 90 degrees to both of the intersecting planes. The perpendicular lines can be found or calculated by the cross product of any two direction vectors that's on both of the planes, as shown in the equation above. The perpendicular lines can be found by the cross product of any two direction vectors that is also on both of the planes, as shown in the diagram above. The reason why cross product is used here is because the cross product of any two direction vectors will result in a third vector that is also 90 degrees to both of the first two vectors, and it proves our point here. After you have determined where the perpendicular lines will be, then you can move on to calculate the exact distance by the means of projection. First of all, you need to find one point on each of the plane that is also on the direction vectors in question. Say point P on plane 1 and point Q on plane 2, and this point can be any value as long as it lies on the plane and on the direction vector itself. Then you will need to connect the line by finding the vector of PQ, of point P and Q, and the equation is shown on the right side. Then you can apply the equation of projection to find the exact value of the distance. An equation of projection is the modulus of vector PQ dot product the normal vector n divided by the absolute value of the normal vector n. And by substituting all the existing information, you will get the magnitude of the exact distance. Projection plays a vital part here because it projects the actual distance between the plane onto the normal lines. Other than that, the shortest distance can also be found on a line and a plane, or a point and a plane. In fact, the method of calculating distance for a line and a plane, or a point and a plane, is very similar to how the distance is counted in the plane and plane scenario. Say you are given a line and a plane. First, you need to find the perpendicular line between the line and the plane by cross product. Then, find one point on each of the planes, say point P on the line and point Q on the plane. Thereafter, find the vector PQ. Finally, apply the projection equation after you have all the information. Again, for the point and plane, the methods are exactly the same as that of a line and plane. First, you need to find a perpendicular line from the plane. Note that the normal does not have to intersect with the point. Then, find a point on the plane, say point Q. Thereafter, find the vector PQ. Then, use the projection formula to solve the question.
Created using Powtoon.